right, perfect. So as I mentioned, I'm Grayson, and I'm at Uffizzi. That's 2 F's, 2 Z's, for those of you who don't know. Rhymes with easy. One of the things that we want to go over is just the agenda, and first of all, we should talk about like what is the cloud? Just very basic question, of course, but I find that knowing this answer gives you a lot better understanding of like how more advanced components work. When I first started, I didn't really understand what the cloud was. It seemed like this magical, nebulous thing, but it's very real, very tangible, and I've been there. So we'll talk about that. Second, I want to talk about why use the cloud. Not that there are a lot of other good options these days. I mean, the cloud is, I would never recommend someone not using the cloud these days. But really talk about the history of like how we got here and how web hosting has evolved over the years, and particularly what problems that the cloud is solving. Helps us kind of understand how we can better use it. Then we're going to talk about, how do users reach your app? Specifically, what are the mechanisms and the components of the cloud that get from, them typing your web address into their browser all the way to them getting your application back, and all those little details. And then we'll talk about a survey of cloud providers. This is not a comprehensive list by any means, but we'll talk about the big ones out there that you probably heard of: AWS, Azure, GCP, and others. And then we'll also look into platforms, which are good options for some users. So we'll talk about why you may want a platform or why you may want an infrastructure provider, and maybe some questions to ask along the way to help you make a decision that's right for you. And then, as I mentioned, we'll wrap up with a demo and show you how easy it is to get an app in the cloud. So basic question is like, what is the cloud? And the cloud refers to specialized computers that are accessed over the internet and serve up software and databases that run on them. These servers are located in data centers around the world. And the first time I saw a server, I realized like, oh wow, that's all it is. It's just a beefy computer. Companies like Dell, HP, Cisco, they make specialized computers called cloud servers. That have lots of RAM, lots of storage capacity, and high network performance. And these computers are, if you can imagine, 2 pizza boxes pushed together. That's about the size of them. Generally anywhere between, maybe 20 to 50 pounds a piece. They're pretty heavy. But they're loaded with hard drives and modern memory and all sorts of other components you find in your typical, desktop computer or laptop, but just beefier, bigger versions of them. The second major concept of cloud is data center. I like to think of a data center as just a large warehouse that holds thousands of servers and then connects them to the internet. The picture in the bottom right, you can see this kind of industrial view, aerial view of a data center. Cooling towers and air conditioning handling units and specialized physical infrastructure that's going to keep this data center up and running. Two things to note are really there are actually public data centers and there are private data centers. Public ones that you've heard of, built by companies like Amazon, Microsoft, Google, IBM. They install these servers into these data centers, and then they rent access to businesses or developers like you or me to use. There's also private data centers, and a lot of large companies like Facebook is a good example of one that build their own data centers. And then also they're common in government, healthcare, finance companies who are more concerned about privacy, security, and oftentimes physical access to the building. There are several private data centers in what we're known as co-location or shared data centers, even here in Middle Tennessee, where we are. A couple in downtown Nashville, a few of them south in Franklin. A lot of these buildings have like physical perimeters around them, so gates with access controls. When you enter the building, there's fingerprint scanners and ID checks, and these server cabinets are locked. And so a big part of cloud security is not just at the software layer, but it's also the physical access layer. So you can imagine if someone gained physical access to one of these buildings or to one of the server cabinets, they could obviously do some damage, whether it be through malicious software or just physical vandalism type thing. So data centers are the fundamental, one of the fundamental components of the cloud, and that's where security starts, at the physical layer. So data centers are scattered around the world, Companies like Amazon, I think, have around 120 or more across the globe. As I mentioned, companies like Google, Amazon, Microsoft build them, developers pay to use them, and then apps and data can be cached at different strategic locations to improve latency or to improve security. Certain countries, for example, may require that data be housed in a geographic region. And so the large cloud providers will build facilities everywhere, partly for that reason. So why use the cloud? I like to say that the modern cloud solves several problems that plagued early web hosting. And in particular, efficiency and cost were big problems, which virtualization solved, and we'll talk about what that is in a second. And then the second one is really the complexity and having to manage a lot of things. And so layers of abstraction have been added so that there are fewer things for you, the developer, have to manage. So before we go into those two concepts, talk about like what web hosting looked like before the cloud. This picture I like to show because as funny as it looks and as much of a rat's nest as it appears to be, this is not too far from accurate of what a lot of early web hosting was. In a closet, lots of servers, network switches, routers, and a lot of cabling connected to your standard electrical outlets. As you can imagine, required expertise. I don't know about you, but I'm not sure what everything in that picture is, and a lot of developers weren't either. So as you can imagine, if you were trying to build a startup or a business or just host a basic app, you had to not only understand the software layer, but also the physical networking and hard drive and server layer too. As you can imagine, also, it's not scalable. It takes time to acquire and configure new servers. And there are upfront costs associated with that as well, thousands of dollars to get started. And then just like your laptop, every few years, it's going to become dated and need to be upgraded and replaced. And it was no different for web hosting and cloud servers. And then finally, it's risky. I mean, because if you think about it, if there's ever a security problem associated with the software you're running on your server, it's your responsibility to patch that software. There's also an issue of reliability. If you're running on a standard power system, your home's power or an office building's power, those things go down sometimes in a storm or whatnot. And so there wasn't a whole lot of redundant systems out there. So a lot of these problems need to be addressed for the modern cloud that we know today to become what it is. So the first problem we'll talk about is the inefficiency problem. This picture of the server over here, let's say, for example, it has 256 gigabytes of RAM, has a terabyte of hard drive space, and a gigabit internet or network adapter. So very beefy machine. The problem with a dedicated server means that only one tenant can use this machine at a time. And it's really typically going to operate at only a fraction of its total capacity. So obviously, there's a lot of expense and a lot of wasted compute power on this server. So the solution is virtualization. And when you're using a modern cloud system or your server instance, a storage device like object storage or database or network bandwidth within modern clouds, you're actually using a software-based or virtual version of the real thing. You're not actually using a full physical server or a full hard drive. You're using a virtual piece of it. And so this is a key concept I'd like to highlight, is that virtualization is the process of creating a software-based representation of a resource. So virtual servers, virtual storage, virtual networks allow you to basically logically divide these resources up into multiple resources. So for example, a server instead gets divided up into multiple virtual machines. They allow you to isolate your apps, your data from other VMs, and then provide you with memory, hard drive space, network access, etc., just for you. So that means multiple tenants can coexist, on this one physical machine. Similarly, you have concept of a virtual private cloud. So in the diagram here in the upper right, you got the larger public cloud. Again, this is like a data center or a collection of data centers around the world. And you can carve out a small piece of it known as a virtual private cloud for your own personal use. And you can set up a secure connection from your laptop to that virtual private cloud, which is isolated from other users accessing other parts of the public cloud. So a VPC, as it's known, can actually span multiple physical machines, and it gives you a private network and exclusive access, again, to server memory, disk space, network bandwidth, a range of internal IP addresses where Applications can communicate with each other privately on a private network, similar to say like your home network, all of that existing within the data center though. And then external IP and other resources can belong to this VPC. Another concept of virtualization is a virtual data center, more commonly known as an availability zone or simply a zone. Availability zones are groups of data centers, or sometimes they're isolated segments of a larger data center that have their own power, their own network, their own cooling, to reduce the chance of two zones failing simultaneously. And so this can be really important for mission critical applications, or things that you just, at least maybe from a monetary standpoint, otherwise you can't afford for them to go down. And these will be, so if you deploy what's known as a highly available application is another concept. This is the practice of running an app or service in multiple zones to increase the redundancy and reduce the chance of downtime. So we'll talk about this a little bit later, but certain cloud providers, you want to look for this feature, high availability, if you have any type of important business critical application. The second problem with early web hosting was expertise, and that being even virtual infrastructure can be complex and require advanced knowledge of both the hardware and software layers. Here's a kind of a smattering of terminology which you may or may not have heard before, may or might not be familiar with. But in the early web hosting days, you really had to be familiar with this entire stack. And so to solve this problem, modern clouds introduced this abstraction concept. And if you're a software developer, you probably know this term. But in the context of the cloud, it may be a little different than you're used to for example, in a software framework. So the modern cloud, it creates layers of abstraction so that there are fewer things you have to manage. And so what is abstraction? I like to give it a simple definition of, it's just the practice of hiding details to let you focus on the essential form or function of something. I like to use this heart example. The heart on the left is a less abstract, more detailed version of the human heart. The one on the right is a more abstract, less detailed version. But effectively, they're the same thing in that they let you, the more abstract one lets you focus on the essential form of the heart. And so analogous to that is kind of the way the modern cloud works. And if you think about the cloud as a stack, at the bottom of that stack, you've got physical infrastructure, you've got a data center, you've got the hardware that runs on it. Examples of these are Rackspace, Amazon, Microsoft, Google, IBM, Akamai, which is a content delivery network, Cisco, HP, Dell, who are making the hardware. Above that, you have all these virtual resources that we talked about, virtual machines, virtual private clouds, virtual availability zones and other resources. And they are providing these with push button or API driven interfaces. So AWS, Azure, Google Cloud Platform, IBM Cloud. These are the clouds that most people think of when they think of cloud computing. These are known as IaaS or infrastructure as service providers. Above that, you have platform as a service. These are also known as PaaS. These are automated services. So they take collections of virtual machines and servers and network and all these other components and apply some sort of automated processing to them so that they kind of work in a more fluid, in a more, batteries included kind of, push button way. This is examples of this for companies like ours: Uffizzi, Netlify, Heroku, Firebase, AWS Beanstalk. They're basically curating cloud services and presenting to a more abstract version of what's underneath, which is the infrastructure. And then, of course, above that, you have SaaS or software as a service, which probably everyone on this call is familiar with as developers. These are mobile and web apps. Now, they could be, SaaS versions of sort of infrastructure things like SendGrid, ways to, automate sending of mail, Sentry, things like monitoring, or they could be consumer-driven apps like Facebook, Gmail, Slack, Spotify, Netflix, etc. So the concept, again, is the abstraction, is that software developers don't have to worry about the data center or the hardware or even the virtual resources if they're using a platform. So as I mentioned early on, there's really no best cloud, and trying to pick what layer makes sense for you. It may be the platform layer, it may be the infrastructure layer. It's probably not the physical layer. Probably one of the two in the middle of like what makes sense for you to leverage when you're deploying your applications. Section 3, we're going to talk about how do users reach your app. So modern cloud providers use a system of content delivery networks, load balancers, domain name system servers or DNS servers, and public and private IP addresses to receive, authenticate, and route requests from users to your app. And we'll go through each one of those briefly. So content delivery networks are the concept of storing static content like images, audio, video, essentially data that is non-mutable, is not really mutable, or doesn't often change. Those can be cached in multiple locations. The caching improves latency. It also saves bandwidth. For example, if I'm here in Nashville and I'm accessing a website, let's say in China, when I make a request to a server, instead of it traveling all the way to Beijing, for example, that data can be cached maybe locally in, let's say, Atlanta or something. And so when I hit that site again, it's going to serve that site up a little bit faster and save on bandwidth. CDNs also help mitigate DDoS, or distributed denial of service attacks. The idea being that it spreads the load between multiple caches so that one cache or one location that's housing data doesn't get flooded by a lot of user traffic. And this is a common problem, especially for big websites like GitHub, for example, who ward off tens of thousands of DDoS attacks, annually, monthly, et cetera. So caching and content delivery networks are really a fundamental component of the modern cloud. Another concept we want to talk about really that's fundamental to how users reach your app is a load balancer. Load balancers receive incoming requests and spread them between multiple servers. So if you have, let's say, 2 clients or 2 users that are trying to access your site, a load balancer is going to receive those requests and then forward those to the appropriate server, or excuse me, to 2 different servers that are both housing your data or your application. So the idea is to spread the load so that one server isn't overly burdened. Load balancers, as you can see in the diagram, have IP addresses, and you're probably familiar with this concept. But what a lot of developers are not familiar with is kind of how IP addresses work in conjunction with ports. So load balancers have a public IP, which is what you're hitting when you visit a site, and they listen for connections on TCP ports, which allow several backends or services to share a single IP. So for example, you may have one IP address like 64.178.25.210, where 3 different services, a front end, an API, and a database are all sharing that IP address, except they're listening on 3 different ports. So that's a way for essentially multiplexing a single resource in the cloud. DNS is something that you may have experienced or been familiar with as well, even if you're not well versed in the cloud. Of course, we don't normally type in IP addresses into our web browsers. We use domain names, and of course, you can buy a domain name from a domain registrar like GoDaddy or domains.com or wherever your preferred DNS or domain provider is. And these domains, of course, mapped to an IP address. And so that when you're hitting that load balancer, the DNS is then mapping it to that load balancer's IP address. And then the final piece I'll talk about is HTTPS encryption. And this is something that this day and age is standard, or at least should be standard across all applications, all websites. There's really no excuse not to have HTTPS. There's no good reason not really to have it. It's also a big pet peeve of mine that this is not like something that's enabled by default for free on all platforms. Some platforms actually make you pay for this. I think it should be absolutely free. But the idea here is that SSL certificates or TLS certificates verify the authenticity of the server so that when your browser makes a connection to it, you can be sure that it's the true site that you're looking for and not some fraudulent or copycat application or site that's going to be stealing data, for example, from you. And talking a little bit about how this works, this process known as the TLS Handshake. So it's a multi-step process where users when you're on your browser and you type in a web address, example.com, a user opens a TCP connection to an HTTPS load balancer. Those responses, the response includes a public key and a certificate, and your browser then can confirm the identity of the server, and it uses that public key to establish a secure session to that load balancer. After establishing that connection, the load balancer then forwards the unencrypted traffic to the application server, listing on port 80. And then, as you can see on the far right, an unencrypted, HTTP request, in this case, a Git users, is sent to the server, and then that returns a response, which is again encrypted. It returns back to your browser. So this process happens automatically when when the SSL certificate is set up for a domain. And we'll talk about this a little bit, but you want to look for services in the cloud that do a lot of this for you, because this can be tedious, error prone, and of course, it's not something you want to get wrong, given that encryption these days are so critical to web security. In this section, we want to talk again about survey of cloud providers. As we talked about IaaS, or infrastructure as a service providers like AWS, Azure, and GCP, they offer a lot of customizability at the expense of time and expertise required to use them. On the other hand, you have platform providers like Netlify, Heroku. Us at Uffizzi, we emphasize simplicity over customization. So that's the trade-off there, that you have to decide what's right for you. And again, there's no best cloud. So you have to look at everything from cost, complexity, features, UX, et cetera, to make that decision. So hopefully, as we go through these, and maybe you're considering a new cloud provider, or digging a little deeper in the cloud, maybe give you some tools and tips and some questions to ask. So first, we'll talk about the public cloud providers that you probably have heard of. AWS, of course, is the first and still #1 public cloud provider. In my opinion, these are all opinion-based. You may have different takes on it, but this is my observation, having dealt a little bit with all of them, some to a more degree than others. But the pros of AWS has a long track record. 2006, I believe it was when they started. Lots of features, lots of documentation, and they have big name customers: Netflix, Twitch, LinkedIn, a lot of big companies that you've heard of trust AWS. The cons: overwhelming number of options sometimes. Got quite literally hundreds of products. Some of them are very similar. It's not always clear which product is meant for what, and they're constantly releasing more. They tend to have, in my experience, mediocre customer service, and they tend to have a complex billing structure. So deciphering what you're getting charged for, why your bill still says you're getting charged for something because you didn't shut down some resource, it can be a little frustrating. Microsoft Azure, #2 cloud provider. They're rapidly growing, as you might expect, and the best place to run Microsoft stacks. However, they do support Linux, and Microsoft generally is starting to open up more to the open source and Linux environments and ecosystems. They have a pretty good web UI, and they have a mature, corporate and sales support network. If you work for a large company in Nashville, there's a good chance you may use Azure and may have experienced some of that yourself. Cons being Microsoft lock-in. That's nothing new really with Microsoft, and generally support for products that compete with Microsoft products tends to be limited. In third place is Google Cloud. They have competitive pricing, probably because they're in third place. They offer some pretty generous startup credits. They leverage, and it's also, you can leverage Google's global scale, of course, being a massive search giant, and also their expertise in AI, which is, I think, at the top of all cloud providers, as well as Kubernetes, which we'll talk about in a bit. But these are things that, of course, they've like created or really pioneered. Cons: they're playing catch up in terms of features, and they have a reputation for discontinuing products sometimes that you may be using. Third, we'll talk about platforms. These are the three I'm going to point out are Heroku, Uffizzi, and Netlify. Heroku is the first app platform built for Ruby apps back in 2007. First popular one. They're focused on like front end and back end apps. They have a long track record, having been in business for over 10 years. Good documentation, and they're generally easier to use than AWS. The cons: that they're very expensive. They're almost prohibitively expensive to use on anything other than free or very cheap small apps. They have a limited free tier. When I mentioned free SSL earlier, they do not offer that. They actually charge you for that, which frustrates me. And there is still manual configuration required for things like static sites, setting up logging, connecting to a database. That could be a bit more polished. Uffizzi, which is a company, of course, I work for, app platform and database service built on Google Cloud and Kubernetes. We have a pretty generous free tier, I would say. You can deploy from GitHub. It auto detects static sites, front-end apps, and back-end apps, and database is an option as well. The cons for us: we're a newer company. We have less documentation, and we also have several features that are still in development, including object storage and a free database option, which is actually coming soon. Then finally, talk about Netlify. Netlify is focused primarily on static sites and front-end apps. They have a really easy to use continuous delivery feature. They have a really fast global CDN for serving up static content. They have good free options as well. Their negatives are they don't support any server-side applications. So you can't run a Node app or Ruby or PHP or Go app. They don't have a database option as well, and it's fairly expensive to add team members. So I like to go with 4 questions that you should think about asking when you're considering a cloud provider. And this really goes, I think, for all developers in the modern day and age. So first question is, can I deploy from GitHub? GitHub has become the central hub for both open source and private software projects. And it's really the starting point, in my opinion, of the cloud and getting apps in the cloud. So you should definitely look for a cloud provider that supports deploy from GitHub. I probably don't need to go over this, but quick refresher, the difference in Git and GitHub. Git is the tool, it's open source. You can manage it yourself, set up your own GitHub server, or you can use a managed service like GitHub, GitLab, or Bitbucket. GitHub, the real benefit there is provides a GUI for your Git, code backups, and a lot of tooling on top of regular Git for merging code, resolving conflicts, reverting commits, collaborating, etc. Git Workflow, of course, write locally. You add and commit changes to your local repo, push commits to a remote repo if you want. You can invite others to collaborate, and then of course pull and merge those recent changes to your local computer. And then that process continues. Just what I think are some interesting statistics on GitHub. It's grown massively in the past few years. 56 million developers now worldwide. The biggest growth right now is in Africa and Asia. 60 million repos created in the past year alone, which is crazy. It's up 35% from the previous year. And there's 1.9 billion contributions last year, making GitHub by far the most popular managed Git service out there. So not that I really need to sell GitHub any more than it sells itself, just some interesting statistics that came out of their new report this year, their Octoverse report. So again, all that's to drive home, really need to be looking for a cloud provider that supports GitHub. Second question to ask is, do you support CI/CD? So you can build apps with greater speed and reliability by setting up what's known as continuous integration and continuous deployment, or CI/CD pipelines, on your GitHub repos so that you can automatically redeploy changes to your code whenever you push new commits. And I really can't emphasize this enough as being a game changer in terms of speed and reliability in terms of deploying apps to the cloud. So this is a kind of an overview of the software development lifecycle. You're writing code, you've got source code, you're probably using version control, Git, and maybe host on GitHub. You have a build process where you're pulling in dependencies, you're compiling assets, and you may be bundling it into a container image, which we'll talk about in a second. And then there's a deployment phase, whether it be to a virtual machine or to containers. You've got storage devices, load balancers, IP addresses, all these virtual components that we talked about. And then there's a monitoring phase. You're setting up logging, alerting, backup schedules, and then you're monitoring your app for consumption so that you can enable scaling or high availability or some other features. And all of that should feed back into your development process. You should take those, the things you've been monitoring, and then incorporate them into code improvements or bug fixes or new features, etc. So continuous integration allows you to essentially merge these merge these changes into your code base through automated tests, for example, a pipeline of tests that may check for syntax and other standard tests along the way. And then a continuous deployment feature is once all those tests are passed and it's good to go, it can be rolled out immediately to your cloud environment. And so there's no manual build process or there's no manual test process. All of it is completely integrated and end-to-end automatic. Third question really is around manual configuration. It's kind of a segue from the last topic, which is how much can I get out of the box that works just works for free. So I tell people look for platforms that leverage modern tools and technologies, particularly containers and orchestration frameworks to automate tedious and error-prone cloud configurations. And really, in addition to that, it promotes better reliability and scalability for your app, as opposed to legacy virtual machine or other more approaches. We'll talk about that in a second. So automation, I like to show these statistics. Automation reduces vulnerabilities. I really can't drive that home enough. 64% of vulnerabilities in the cloud are caused by human error, and 99% of all cloud vulnerabilities go undetected. Probably don't have to remind everybody about the constant hacking and data breaches that happen all the time. So automation is really a way to fight that by setting up best practices and codifying them into code and into things like CI/CD pipelines. You can really help to prevent mistakes and errors. A huge number of problems are caused by just defaults not being changed, or default password on your MongoDB instance or something. So automation can kind of help prevent those bad events. So I mentioned containers a couple of times. You may or may not be familiar with this concept, but it's a way to package an app and its dependencies in such a way that makes them portable and easy to run in different operating environments. And a container image is a lightweight, standalone, serialized or binary package of software that includes everything you need to run an application. So that means the code, the runtime, system tools, operating system libraries, settings, etc. So it's this autonomous unit of software that can be freely moved around the cloud. So this is a common question. What's the difference in a virtual machine and a container? Because they sound similar. Without going into too much detail, virtual machines use what's known as a hypervisor. It emulates the underlying hardware. And in particular, you're running multiple guest operating systems on top of that virtual machine. So if you recall that image of the cloud server with the different VMs on top of it, each one of those VMs is running a Linux OS or a Windows OS or whatever OS is installed on each one of those VMs. On the other hand, containers actually share an operating system, and they do kernel level isolation, so it's not at the hypervisor level, and they use what's known as a container engine, particularly most commonly Docker, to perform isolation in the packaging. So at a glance, virtual machines, they use a hypervisor. They have independent OSs versus no hypervisor and share an OS. VMs have limited performance, whereas they have kind of an overhead because of the hypervisor. Containers, on the other hand, have native performance, meaning that they are going to be as fast as the underlying hardware allows. Virtual machines are heavyweight in terms of just byte size, whereas containers are very lightweight, generally on the order of 10 megabytes to maybe 300 megabytes. They tend to be less portable, virtual machines do, than containers. And also, virtual machines will start up in a matter of minutes, whereas containers will start up in milliseconds. So they're lightweight, fast, portable, and really are agile in a more modern way to really deploy software these days. You've probably heard the term Docker. Docker is the most popular runtime toolkit for building, running, and managing container images. The Docker CLI allows you to do things like Docker build and create those container images, and then modern cloud environments will be able to run those. Kubernetes is a term you may also know and have heard. This is a completely own hour-long discussion or hour-plus, week-plus conversation, because Kubernetes does have a reputation for being complicated. However, it's very powerful, and it's a framework for orchestrating the life cycle of containers. So starting, stopping, restarting, monitoring, setting resource limits on your app, setting access controls, enforcing network policies of what services and where connections can come from. So it's kind of this orchestration framework for containers. And the fourth and final question I have people make sure you ask for when you're considering cloud is, do you offer a fully managed database service? managing your own database is challenging, and the consequences of getting it wrong are severe. So you really need to ensure that your data is, in order to ensure that your data is secure, scalable, backed up, you really should look for a fully managed database service, and we'll talk about what that means exactly. So the difference, the other option instead of a fully managed would be a self-managed database. Self-managed requires manual configuration of infrastructure, whereas a fully managed database, it's just push button and it's going to stand up for you. Self-managed also requires manual upgrades of storage capacity, manual scheduling, and storage of your backups, manually upgrading versions, manually patching security vulnerabilities, and manually setting up and syncing high availability servers. So if that sounds familiar, it sounds a lot like the early days of web hosting, where a lot of it is your responsibility and there's a lot of manual steps involved. Really encourage you, if you're looking for a database option, to consider a managed database where all of this is taken care of for you. Other things to look for, features like auto scaling, in particular horizontal auto scaling, which means when there's an uptick, for example, in traffic to your application is going to replicate itself. And if you remember the load balancer diagram, it's going to be spread across multiple servers, and a load balancer is going to maybe round robin between those instances to make sure the load is spread between them. Things like zero downtime deploys. This means that when you're doing something like continuous integration and continuous delivery, when you're pushing a new commit to GitHub and that's triggering a new deployment, you don't want your app going down in the process. So you want your app to stay up and live. So look for clouds that offer that. Third thing, managed HTTPS certificates. We talked about that TLS handshake. Using a cloud provider that takes care of that for you, takes the guesswork out of it, prevents you from shooting yourself in the foot and not setting them up properly. Backups, again, kind of mentioned that related to the databases. High availability, also mentioned that one, but that's one that you really should pay attention to, because a lot of cloud providers do not offer that as like a push button or add-on type of feature. Self-healing, this is a feature of Kubernetes or another intelligent orchestration framework that can actually inspect your container, and if there's a problem detected with it, they can restart it or maybe spin it up on a different cloud environment, maybe. Global CDNs we talked about, that can really improve the performance of your application, especially if you're serving a lot of images or video. And then authentication services are something else that you may want to consider if you don't want to handle user management, credential management for your users. So summarizing, the big ones here, the developers cloud checklist are Git and GitHub. Definitely be using those. You probably already are. CI/CD is a game changer in terms of productivity. Automation generally, looking for automation will improve your speed of development and also your security and keeping yourself from making mistakes. And then also fully managed database service. And the talking's finally over. I do want to show you guys a demo of Uffizzi, our app platform, and kind of what you can get with some of these features. And I will exit here. If you want to follow along, actually, let me show you this slide. If you want to follow along, you can go to uffizzi.com. You can get started for free. It never sleeps. You get a custom domain, or you can use a default domain that we provide, and free HTTPS are involved. So what we'll do is, I'll show you here in a second, but I'm going to give you an overview. So we're going to create a cloud environment. We have available free, small, medium, and large sizes. We're going to import our app specifically from GitHub. You can also import it from Docker Hub as well. We'll configure our app, which in this case will be very simple to do. And then we'll deploy that app. And then finally, we'll show you how you can monitor it with the logging statuses and turn on and off things like auto scaling and continuous deployments. All right, so I will switch over here to Uffizzi. We'll go ahead and sign up here, uffizzi.com. And I'm going to create an account real quick. And I'm just going to use this password, and I'm going to change this later. So you get a free trial in addition to being able to use our free tier. So right now we're offering a limited time $50 credits for 30 days. It's just saying that if you got something that costs money on here after after 30 days, you gotta put your credit card in. So as we kind of mentioned or alluded to, Uffizzi lets you deploy apps direct from GitHub, and we're backed by Google Cloud and Kubernetes. So you're getting a lot of those features, those automation features that we talked about. Here you can choose an app environment, free, or you can choose one of these larger ones. You have the option of enabling auto scaling or high availability. This is just a checkbox, which it does affect the price, but it will be automatically set up for you. Go ahead and just choose a small one right now. We'll import from GitHub, as I mentioned, and it's going to ask me to allow Uffizzi to install the Uffizzi app on my GitHub repository. This is a read access only, so we're not actually writing anything to any of your repositories. Got it. And actually, I think I'm already. Let me make sure I may be already set up on here. Just a second. Let's see. Yeah, I'm actually gonna uninstall so we can show this real quick. Got it. Okay. So let's try this again. There we go. Just to show you guys, I already had it installed when I tried it earlier, but I'll install and authorize Uffizzi.com to install the Uffizzi app on my GitHub account. I'm giving it permission to look at all my repos, public and private. I'm going to select just a simple, I'm going to do a Node.js application. So right now, Uffizzi is importing this repo in. I can see the master branch. I can choose a different branch if I wanted to. Continuous deployment is turned on, so this will allow me, this will let Uffizzi automatically redeploy my app every time changes are made to this branch. So let's sit there and watch it, and we'll trigger redeploy if I'm pushing new changes. Configuring our app, this app just listens on port 80. There are no environment variables for it, but I could add those if I wanted to. For example, to connect to like a third-party API or MongoDB or whatever, S3 bucket or something that I wanted to connect to. I can do that through the environment variables here. The database option, right now we're offering MySQL and Postgres. We're rolling out, starting at $20 a month, we're rolling out free versions here pretty soon. Fully managed, automated backups, auto scaling up to 30 terabytes, so plenty big for most people, and then a multi-zone or high availability option as well. And so I'll choose a Postgres. I'll just choose our standard small size. I can turn backups on or off. I'll just turn them off in this case. So I'm getting 5 gigabytes of storage. This option in particular has no HA enabled. And you kind of see the hourly rate you can expect to pay. So my application here is ready to go. I've got my app, my cloud environment I created, a small environment, the app I've added, and a Postgres instance here. And then I'm going to just click deploy. So congrats, your app's being deployed. We also are offering, just rolling a new feature we're calling our Uffizzi community page. We allow you to actually post your application to our, it's kind of a Hacker News style page where you can showcase your application, get feedback on it. People can clap for it and see what you got running. And you can explore other apps that are running on Uffizzi. In this case, it's just a simple hello world, so I'm not going to do that. But here we go. So this is our dashboard. We've got our hello world application, which is in the process of building. As you can see here in our activity log, I can drill down into these logs and see what Uffizzi is doing. So it has automatically detected that this is a Node.js application and is pulling dependencies, bundling assets, and is building it because it knows it's Node.js. So all that's being done automatically under the hood for you. In addition to that, as I show, we've got a Uffizzi Postgres instance standing up, and this will take a few minutes to configure. But once it's up, you'll see that that there's an admin console, a GUI that you can go in there and create tables and users and that type of thing within your Postgres instance. And I can also configure my database settings. I can see how to connect to it here, etc. One thing I will show also, Uffizzi also makes connecting to a database really easy. So if I go to my container here and I go to manage the settings, when you add environment variables, we do something really neat where we auto suggest things, common things. So like if your database needs a username, for example, you can go here and just select username, and Uffizzi will fill this in on the back end. So we'll pull that database's username or that database's hostname, password, URL, etc., and we'll plug those values in for you. So it really makes it easy to connect your application to a database. There's no CLI you have to use. You just do it all through the GUI here. Yeah, and it should take a couple minutes. The other thing that you can turn on and off continuous deployments. We've got them on as we showed. So this will allow me to push an update to my repo here. You'll see every time a new commit comes in on my master branch, you'll see it being redeployed here within Uffizzi. So it's finally finished building. It looks like it was successful, which is good. And then we'll just wait here a second, and it should be up and running and ready to go. The other thing I'll show real quick is in our environment settings, we can set up our HTTPS. All we have to, and it's a guided setup process. So you can add a custom domain if you have one already. myawesomeapp.com or whatever. I can go through here. I can take this IP address and I can plug it into my domain registrar. If you need help doing that, we actually give you some quick links to popular domain registrars that will walk you through how to add, create an A record, for example, for your application and add this IP address in there. And then you just basically give it the domain that you purchased, and then we'll set up a TLS SSL certificate. We'll handle all the encryption and the handshaking, so that this environment will have HTTPS and be ready to go for prime time for business applications or storing user credentials or whatnot. All right, so now we have our app running. We'll go check it out. We'll open the application, and there we go. We've got our Hello World app running in the cloud. As you can see, there's an IP address that we just saw, and we can plug this in as I mentioned, into our domain registrar, and we've got our app running. I will real quickly, and I'll wrap up, show you the continuous delivery option. So I'm in here in Visual Studio. I can make a change. It's my application. I'm just going to say hello, Grayson. I'm going to save this. I'm going to save it. I'm going to push it with a new commit. Say new wording. And then I'm going to push this to my GitHub repo. So there we go. It has been, my branch has been updated. If I switch over here to Uffizzi, you will see here in a second the build process happening. There we go. You can see that it's building again. I can see Uffizzi is checking the repo, rebuilding the image, and it will redeploy that here in a second. And so once that's done, you'll see hello Grayson. Let's see if it's ready. Still building. And by the way, Uffizzi automates about over a dozen different cloud processes. So there's a lot going on under the hood here. But give you a bit more insights. It's actually a Kubernetes cluster that you're running on top of. It's a pod, and we're effectively redeploying those containers on the pods in that Kubernetes cluster. So you can also think of Uffizzi as sort of a dashboard layer, a control plane layer for Kubernetes as well. Let's see if our app is updated. Not quite. There we go. Now it's successful. Switch. Let me do this anyway. Switch over here. We should see Well, it may take DNS a second to update. There we go. Hello, Grayson, and now you can see that my application is up. You notice there was no downtime here, so my application Hello World was up that whole time, even though we were building a new image and we were doing a rolling update. So we were pulling down the old application and deploying a new application. Hello World was up the whole time until Hello Grayson was ready to go, and that now the users are seeing Hello Grayson. So anyway, that wraps it up. I don't think I have anything else for everybody. Let's see, last slide is just thank you. Feel free to contact us if you have any questions. I'm happy to make these slides available. I'm Grayson at grayson.adkins@uffizzi.cloud, or you can send us a note to info@uffizzi.cloud, and we're happy to chat with you or maybe give you more information. So anyway, William, that's all I got.
Awesome. Thank you so much, Grayson and Josh. That was a great presentation. I'm sure folks on the channel here learned a ton. There's a couple questions in the chat if you have time.
Yeah, for sure.
Gilberto mentioned, he said not sure if he saw it correctly, but looks like you were showing that you can set environment variable values from a database. Could you touch on that again?
Yeah, for sure. Let me go back and share and demonstrate that again. So let's see. Can you see my screen? Yeah. So for example, let's say I wanted to add like a new application, something like, in this case, I'm going to pull from Docker Hub. If you so you can also pull images straight from Docker Hub, and I can grab things like, let's say WordPress, for example, is a good example that most people know. I'm going to choose the latest tag here. I'm going to go next here. In the environment variables section, WordPress, if you check out the Docker Hub docs for WordPress, there are certain environment variables that are required to connect to a MySQL database, for example. And I think I actually selected Postgres, so this is not going to work, but hopefully you get the idea. So there's WordPress DB host, WordPress DB user, WordPress DB password, et cetera. These are all required to connect your WordPress site to a MySQL database. So I can actually take these variables that WordPress requires, and I can plug them in here. And then instead of like having to understand like dig into my database and figure out, okay, what is my host name for my database, or what is my like username or password, Uffizzi offers these, they're templates, they're placeholders, they're basically variables that we will create those values for you and inject them in once you deploy. So I can sit here and add, all of these, values in here and not have to worry, or excuse me, I can add all the names in here, the keys in here, and not have to worry about the values. And so that when I deploy, the app is automatically going to connect to the MySQL instance. And we do that through some fancy virtual networking, some VXLAN technology. But anyway, through some sidecar proxies and Kubernetes. Important thing is that you don't have to worry about all that. We just automatically connect it for you.
That's cool. And can you still view the actual values,
Yeah, absolutely. If I go back here into this, if I go back here in this environment that I was showing earlier, here's that MySQL Uffizzi Postgres database. You can see those connection values here, the literals. And so if you have another use for them, they're here. And I can see this password and edit these if I need to. Awesome.
Yeah, I was thinking for things like post-to-co or whatever, like if I wanted to connect to it and query the database.
Yeah, yeah. So so right now the Uffizzi to connect. So connections were only allowed right now on Uffizzi through internally. So it would need to be an application running in the context of this environment. We actually block external connections to the database for security reasons. So if you want to run an application that talks to this database that needs to be in this environment, this White River environment.
Gotcha. That makes sense.
Yeah.
So one other question, it says, does the zero downtime apply to the databases as well? For example, if the data in my database needs to refresh nightly and could require a long time to refresh, will the prior version of my data continue to be available until the new data is available?
Yeah, in terms of refresh, you're talking about like snapshotting exactly, or I'm not sure what you mean by refresh.
Yeah, I'm not entirely sure either.
So generally, I can describe what we do, and hopefully this answers the question. So for a highly available database, we actually run 2 different database server instances that both are, so if one were to go down, the other one would pick up. There's a primary and a secondary. So generally the database is available and is not going down. All the data is snapshotted daily, and that's stored in like cold storage, like cloud storage, yeah, and so it's like highly redundant data that's backed up, and it's it's available. So we don't do any kind of downtime, or when there's maintenance that happens, which is regularly scheduled, which we handle, and patching, there's not a downtime in those cases either.
Awesome. Great. It looks like Josh is going to get in contact with the person that asked the question as well, so they can probably help better answer that question. But
yeah, I've got engineers that are smarter than me who can probably answer these better. So
cool. Awesome, man. Well, thank you so much for this talk. The platform looks really cool. Definitely looks like you have a really good eye for ease of use and simplicity. Man, I might have to like whip out my credit card and move over to the NashJS site to try it out. Yeah, it's pretty cool, man. And awesome. Well, and also just props to you all for making a Nashville team. Like that's super cool, and we love that, especially on NashDev and NashJS to feature teams and SaaS products that are here in town. And awesome. Well, thank you so much for sharing. And is there any last things you'd like to share before we end the meeting?
No, I think just check us out. Support local Nashville if you're here. Also, again, I'll hit that community page up again. If you're someone who's like built an app and wants to like get it out there in the world and get users, we're actively looking for submissions for it. So again, it's like Hacker News. You can just post your app. We're gonna be like tweeting at our company account's gonna be tweeting those out. We'll be promoting some of them. So if you want some free publicity for your app up there, we're happy to. Oh, Josh. Sorry.
Yeah, hey, thanks, Will. Thanks for having us. We'd love to get some more love from the Nashville community. So I post a lot in NashDev, and I think sometimes people are not sure what to. Well, I guess I don't know. If we could get some more feedback, that'd be awesome. And then please blow us up on social media. I'm not afraid to ask for some love from this crowd as we're trying to take this national.
Awesome. Yeah, for sure. Well, cool. Thanks so much again. And yeah, if you have any other cool, interesting things to talk about in your stack, we'd love to have you back anytime. So appreciate you all.
Absolutely. We'll refresh and come back again later.
Sure. Thanks, guys.
Take it easy. Bye.
Yeah.